Okay, I am starting again from the
Yes,
beginning. Okay,
yes, yes, sir.
Bismillahirrahmanirrahim. Okay, so we have VFD, variable frequency drive. Everybody knows that it's abbreviation, and these are the different names by which you can call the VFD. And if we talk about the purpose of VFD, so we have pumps and fan applications, control and regulation. Here, I was talking about control and regulation. So I was telling you that do not limit the VFD to increase or decrease the speed of pump or any other object. Okay. You can
Okay,
control as well. What you can control the limits. You can set some limits. Okay. You can control the torque. You can control the direction. Okay. You can uh, get the feedback of the encoder as well. Okay. So
yes,
this is not just the thing that you can increase or decrease the speed of something, but you can control something. This is something, more innovative things you need to adopt from that way. Okay. Control, when it comes to control, there are a lot of things when you talk about control, and when it comes to control, there are a lot of things, there are a lot of varieties you can see, you can talk about, you can have faults, different faults when it comes to control. But in regulation, you can just increase or decrease the speed of any motor or any pump. Okay, so this is relatively, narrower side, but this is the broader side of the VFD when it comes to control. Speeding up or slowing down a machine or process, this is something what which we have discussed. Protection from overload currents. This is what which I talked about, the feedback of system. If you're having the surges, electrical jerks, so what VFD will trip automatically. Okay, it will save
yes,
you.
yes, yes,
It will protect or safeguard your output of the motor, which is motor obviously. Safe acceleration. It will start smoothly. It will not start at once with the jerk, with the mechanical jerk. So it will start smoothly. Okay. So
yes,
yeah, what happens in delta? If you use the delta connection, what happens? The motor starts suddenly with the jerk, with the mechanical jerk. So it will be possible that it will, you know, it will damage your mechanical part, which will be more,
yes,
which will be possibly connected with your uh, uh, you can say it with your shaft of the motor. It could be your pulley or any belt or any etc. You can say. So it will start smoothly. So here, the block diagram of the PFD.
yes.
This is very simple. This is what happens.
Yeah, this is
You are
very
having the
simple.
three phase, okay, 380, 360
Yeah,
volts. There's a converter. This is the converter. The part which converts AC into the DC
AC to
current, it
DC.
is converter.
Yes, yes,
Then
AC to
after
DC.
that, you will be having some capacitor banks likewise. And this is the DC
Yeah, yeah.
volt. Okay.
Yes,
The positive and
yes, yes,
negative or vice versa.
yes,
Once
yes,
you converted your three-phase AC into the DC, it will go to the DC filter. It will filter out your, the
yes, yes,
noises will
yes.
be filtered.
Yeah,
And
noise will
after
be
the
fit.
filtration, these two volts bar, positive and negative terminals
Yes,
will be gone towards the inverter section. Inverter and converter. Most of the student get themselves confused that what is the difference between inverter and converter. They both are converting, but when it's a tradition, when you convert AC to DC, it will be considered as converter. And when you convert your DC again into AC, or you convert DC for the first time into AC, it will be considered as inverter section. What
inverter
happens
section.
in the
Yes,
industry, in the industries, if you are using more VFDs, like three or four, more than one VFDs, so what happens, you need to add the inverter section, because these lines are common, these two lines are common, positive and negative. Suppose it is generating 360-volt DC or 560-volt DC. So what will happen if you have two motors and you need to run the two motors on different ways? If, let's say,
yes,
if you are running one more, if your motor one is running in the force 360 rpm and the second motor is running 630 rpm, so what you will have, what you need to do, you need to add these two lines particularly, and you just need to put a single inverter section and set the parameter of this inverter, because this is something what which you have, which can be dealt as common two lines. Are you getting my point?
yes, yes.
Yes. So the same thing happens usually in industries, and the student or the freshers get themselves confused as what is happening around us, around them. So usually this is the inverter section which we have talked about earlier as well. This DC will be converted into 360, but this 360 and this 360 are not same or same. Yes, it depends upon the nature, that it depends upon the parameter setting which you have set. Okay,
Yes,
so this was the block diagram of VFD. And if we
yes.
talk about basics, so these are,
Waveforms.
PWM waveforms. You can see pulse width modulation, voltage is different. These are some basic things. You can take a screenshot as well. All VFDs need a power section that converts AC power into DC power. That was something, converter
Yes, yes.
section. This is called converter bridge. You will be able to see the converter bridge if you open the VFD. Sometimes the front end of the VFD, the converter is commonly a three-phase full diode likewise. Okay, so you need to just read components of VFDs, vacuum tubes, thyristors, transistors. These are the major components of the VFD which works.
Okay.
Yes, this is important thing. VFD system.
Yes, yes.
Can you analyze what is happening here?
Yeah, yeah. This is the three-phase AC current. This is converted, and after converting is the DC bus.
Yeah,
The DC full wave is this,
yeah,
and
yeah,
the filter. Yeah, this is the filtered DC. After converting the is DC bus, this
yes,
signal is filtered DC,
yeah,
and again it is filtered DC. It will inverted,
yeah.
and it will
But
make
the
three
one
phase.
important thing which I want to mention over here, that if you see,
Yes,
this is what this is control logic. Okay,
yes.
it could be output
This
of your
thi-
motor. Yeah,
this
yeah, ask.
control logic, sir. Sir, one minute. The control logic, the inverter,
Yeah.
the control logic showing both side converter and
Yeah,
inverter
sometimes
means
it's, yeah, you can consider it as a feedback, but feedback needs to send. If you are familiar with PID controllers, what happens? You send the feedback, and again the altered
out.
value
Yes,
upon the feedback signal will be sent back again towards your system. So that is something what, for example, uh, if your motor if your motor needs greasing, so what happens? It will calculating the time that when you last time grease your motor. So the time will be set over here. And if your motor is working on encoder, so encoder's value will be sent by the inverter, or like with the temperature of the gas likewise. This is something interesting. VFD system input is here. This is the bridge rectifier which we have talked about earlier. And after that, once you rectify the three-phase AC into the
yes, yes,
single DC, plus minus terminal, you can see there's a
yes.
plus and there's the ground or minus. There's the voltage.
Yeah,
This part is doing
cap
something,
capacitor.
yeah, this is the capacitor for
Yes,
decreasing the noises of filtration, you can say. These are the
filtration.
IGBTs, six IGBTs for first section, third second, and then third section. You can
Yes,
read about that. uh, IGBTs, insulated gate bipolar transistors. The purpose of them, what are the, this is the gate, this is a collector emitter, and then after this could be connected with the output of the drive, which is obviously your motor. What happens? You just control the gate pulses of the IGBT. If the
yes.
PWM which will be given towards the gate of the IGBT will be high, the frequency will be high, because it will come turn on and off in that way. Okay,
Okay.
this is the PWM which I talk about, AC to DC
This.
converter. Yes,
Yes,
these are some examples you can do. Terminals and connections. This is something what which is more interesting.
yes,
This VFD, how can you control, terminate, where to use a variable frequency drive used in a drive system consisting of the following three main subsystem: AC motor, controller, operator interface. Okay, now talk about AC VFD components. So there are a few important things and a few are not important, but but you have to familiar with all of them. So the
Yes.
first thing is very, have you have seen probably that
Cooling fan.
cooling fan.
Yes,
It
yes.
is
Cooling fan,
so
heat
heat sink
sink.
the purpose because it will dissipate heat. So you need to connect the heat sink. Okay. AC to
Yes.
DC inverter. Two transistor per module. This is you can see here first module, second and the third module. Okay. So once
Yes.
your three phase will be converted into the DC, these are the DC buses. You can see DC bus which will be consisting on or compromises of positive and negative terminals. AC to DC converter. Now this is the AC to
Two
DC
diodes.
converter here. Yeah. Okay. So from if we start from very basic, so AC power input is here. You provide three phase AC here, then it will be converted into DC. These are the DC bars, and then what will happen? It will be sent to your motor. Okay. So
Yes.
these are the DC bus capacitors. These are the capacitor which we will discuss later, and this is the
Yes.
power output of the motor. Okay.
Yes.
So these are drive operations. I am here to talk about that. Connection. These are the advantages control of process temperature and pressure. Maintenance cost can be lower. These are a few advantages of your VFD. And save energy. It will save your energy, limit the torque. That is what which I was explaining you the torque, limit the torque and control the torque. If you talk about these DTC or scalar mode, functions and features. Setup parameters. What is this? You need to set the parameters, which also known as the motor ID rent. If
Yes.
you are using a motor with a VFD, and let's say if your VFD is not working or just showing some error or garbage value, and if you want to change your VFD, if so what will happen, you need to connect the VFD, but before connecting with the motor and power up, you need to perform the ID run of the VFD. You need to set the few parameters with respect to the motor's nameplate, and once you set the parameters of with respect to the motor nameplate, you need to run your VFD. Okay. The control
Yes.
method. What is the control method? The control method, DTC, the scalar mode. These are some, advanced things which we will cover with respect to the lectures. Okay.
Okay.
Acceleration ramp rate. What are these things? Automatic restart, stopping method. Stopping method, we have two stop method. Uh, First for 0 and 1. The zeroth one, it will be your motor will stop with the deceleration time, what what you set in the parameters. And the other, if you do not set the deceleration time, so what will happen, your motor will be stopped by the with respect to the load which is connected, which will be connected to your shaft of the motor. Okay, you are getting my point.
Yes. Yes.
This is automatic signals application, which we have seen water supply pump application, conveyor. You can use
Conveyor.
VFDs in conveyors. Okay, reverse
Yes.
forward
Yes.
if you want to. And exhaust fan application, compressor. Most majority in cases we have seen the VFDs are connected with compressor. Okay, these are conclusions. And I'll share this slide with you.
No, sir.
I will share. I will share.
Okay.
Let's suppose this is the nameplate. This is a very interesting thing. Uh,
Yes. Yes.
yeah, I'm not explaining much about theories or theories. I'm just explaining you about the practical knowledge. Yeah, somehow it
Yes.
relates
Yes.
with the empirical knowledge as well. So AC draft model, this is the model number shown here. Inputs specs, inputs specifications are written here. Output, the input is three phase, 200 to 240 volts, 50 to 60 hertz, 5.1 ampere. If you talk about output specifications, so output three phase, 240 and 1.6 kVA, 0.7 kilowatt, 1 HP. The horsepower,
Yes.
or
Yes,
Output
yes,
frequency range, what is the range of output frequency? So it's the range of output frequency is 0.1 to 60 hertz. This is the
yes.
output range of the motor. I'm talking about the motor because this is the nameplate of the motor.
Okay.
AC drive motor. Okay. Software version is it is a, you need to set these things, okay, into your
Yes,
VFD.
yes,
This is a model explanation. VFD series, the name of the model 007. These are the things which you can come to know about by reading the
yes,
manual of the VFD. Okay. So
yes,
the
yes,
things will be same, the constituents will be same, the factors, the components, the determinants will be same, but you need to read the manual thoroughly once you
yes, yes,
start perform the ID run of the motor. Okay. So usually the input side of the terminal can be mentioned by L1, L2, L3 or RST, and the output side will be uh, considered as UVW and T1, T2, T3. Okay.
okay, okay. Yes, yes,
These are the, external structure. It could be different in any brand. It will be varying with different brand. Okay, it will be varying with brand to brand. So you need to stay with the manual. And if you know the basic details of the VFD, you can, you will be able to learn any of the brand of the VFD. Okay. So this is the A part. This is a digital keypad from where you can reset, run, stop, ups and down keys are shown over here. And the B part is here, the NPN and PNP. I will teach you about that. What is this? And the C part is
yes,
ACI and AVI, analog control, analog current input and analog voltage input. This is the section. C part is what? ACI, analog current input, and AVI, analog voltage input. We have learned about that. We have two types of signal: 4 to 20 milliampere and 0 to 10 volts. So if you are sending or receiving, if you are receiving from PLC 0 to 10-volt signal, so you need to connect two wires into AVI. And if you are sending output of the frequency, which will become the input of the VFD, okay, if
yes,
I have PLC and I'm controlling this VFD through my PLC, so what will happen? I will send 4 to 20 milliampere, two wire signals will be connected
yeah. See,
where? At the ACI terminal,
ACI,
which is analog
current,
current.
current
Okay,
input. Yes,
AV, analog
voltage
voltage
input.
input.
Yes,
This is the input of VFD, but it that would be the output coming from the PLC. The output of the PLC will become the input of the VFD. Okay. So at the T point, we have external terminal. If we want to, if we want to change the direction or stop the motor from the external push button, so we can connect over here. We will obviously see this in very detail. Okay. And I will
yes,
put this lecture in my YouTube channel. If anybody has any questions, they can ask. This E part, what is RS-485 protocol by which you can, communicate the drive with HMI as well. Communication port. Okay, so this is very important internal structure. If we talk about that internal structure, let me tell you,
okay.
zoom it. I hope it is shown to you.
Yes, yes, yes,
That's great. So if we start from the input side,
yes.
so
This,
what will happen here? This is something, this is the block diagram you can say, but this is the internal structure of your VFD. Okay.
yes, yes.
If you provide, the through the fuse, the L1, L2, RS,
L2.
yes, so
This
T1, T2,
output
T3 are the output
UVW.
of the
Yes,
motor, which can be, mentioned by UVW. There's the earth.
yes, yes.
This is M1, M2, I1, MI2. These are the, the function, the hardware side of your VFD, by where you can just connect it the push buttons. Okay. The first,
Okay.
if you talk about the first one, it is forward stop. The
The
second one,
stop,
reverse
reverse
stop,
stop,
steps. You have different things
multi.
which will be learned by
Oh,
us for the passage of time.
yes,
And I want to show one thing. that I was talking about, ABI and ACI. ACI and ABI, this is the 10-volt supply. Okay, this is a
Yes.
10-volt supply. You can connect the potentiometer here as well. Okay, this
Okay.
10 volt, and it will, this 0 to 10 volt will be controlled by this potentiometer and will be sent, okay, will be sent to the AVI section of your motor. Here you can see
Yes. Yes.
this is the RS485. If you want to connect the terminals of this, you can just read this as well. Okay,
Okay.
I will send this lecture to you as well, and the section is just about to over, so I will share this. Okay, I will
Yes.
continue
Yes,
this.
sir.
Okay, I'll continue this. Thank you.
Okay.